Okay, so this is quiz 3, question 14. Okay, so it's asked you what is the relationship between 1 and 2. Okay, so 1 is in a zigzag form, 1 is in a Fisher projection, so it's difficult to compare. So what I will do is I will change 1 to Fisher projection, then I can compare. Okay, so if you look at 1, okay, now I want to change it to a Fisher projection, but in 2, you have BR and this group both pointing the same side. Okay, so remember in Fisher projection, the horizontal line are pointing towards you, the vertical line are pointing inside. But now, if you look along this line here, BR and this group are opposite side, one pointing this way, one pointing this way. So I first need to rotate this molecule such that I put both on the same side. Okay, so if I do this, then I should get the following. So I rotate the molecule such that I put the alkyne on the same side. So if you look at this line here, now the alkyne is on the same side. Okay, so because of that, then now I can tell which one is the how to draw the Fisher projection. Okay, so this is this one here. So after I rotate, there's no change on this carbon. So see about CH3 here, you have a wedge hydrogen here. So once I rotate, this CH3 was at the back, but once you rotate 180, it will be in the front. Okay, so if you have difficulty seeing that, you must try to make a model and then rotate this bond. Okay, so you rotate this bond. So you rotate this bond 180. This group here will go here, and then this will go to the front. Okay, so if you cannot see the 3D, try to make a model. So that's what you will get if you rotate this bond 180 degrees. So once you have that, then now this picture is the same as this. Okay, so this is the alkyne here. There's the Bl here. There is the blue CH3 here. There's the blue H here. And then there's the CH3 here and the H here. And now you want to look, you want to stand like this, and then look through this rectangle from this side. So once you have that, then you will see this picture will become the following. Okay, you have the bromine. So if you look through here, if you look through this direction here, you will first see those 4 groups, and then bromine and the alkyne will be at the back. So if you stand like this, your head is on the side of the bromine. So bromine will be here, and the alkyne will be here. Okay. So once you see that, if you look from this direction, on your top right hand corner you have an H. Top left hand corner you have a CH3. Okay. And if you look through the side here, the bottom left hand corner you have a CH3. The right hand corner you have H. So this is the Fisher projection of 1. And now when you compare 2 and 1, then you can see the top carbon here, this top carbon here, and this carbon here are in fact identical. Okay, and the bottom carbon here is a mirror image. So one the same, one opposite. So because of that, they must be diastereomer. Okay, that is why the answer is diastereomer. So the key point is you first need to change 1 to the Fisher projection. But before you do that, you need to rotate this bond first to make these 2 sides on the same side, because that's what you have in 2. Okay, so by doing that, then you can make the Fisher projection of 1. Then you will see that 1 and 2 are in fact diastereomer, because one chiral carbon is the same, the other chiral carbon is on the other side. It's a mirror image. So because of that, then one mirror, one the same, and therefore they are diastereomer. Okay, so if you have any question, feel free to come to ask me in my office.